Screenshots are allowed. Afterwards, we will share our material. Okay, let's start. Data science for dummies. Let me first introduce myself. So I'm Frank. I discovered data science, I think 15 years ago, when I did the Master of Marketing Analytics at the University of Ghent. And that's where I learned all the database languages like SQL, SAS, learned about market research and about all the statistics, about segmentations, prediction models. And that's where I really got fascinated about data science. I immediately started after that as a consultant and a little firm in Mechelen. And those guys were working, we were working for companies like Orange, the Orange Group, Telenet, KBC, and Kinepolis. So at that time, it was mainly the big companies who had like a lot of data. So I had like a lot of fun up there making prediction models, segmentation models, did as well BI reporting, dashboarding. Over the years, I gradually moved to customer value management. That's one of the applications where data science make a big impact. It's where the field within marketing, where we look at the customer and look what the value that customer brings. So we do a lot of campaigns, tactics to keep our customers, to make our small customers bigger customers. And that's where you really see an impact of all those actions. And it's one of the fields where with prediction models, segmentations, you can make money. And I've been continuing doing that when I did the move to corporate for Carrefour in Belgium. And then the last 4 years at Digital in the Americas, in the Caribbean, where we really worked on retaining our customers and upselling and cross-selling our subscribers to make more money. So what are we going to talk about today? I'm going to start with a few concepts, a few buzzwords, things like that, explain a few things. Then I would like to show you guys a real use case. It's applying data science for an e-commerce company. And then I would like to end with, okay, if you've done your data science, what's next? And then specifically within the whole growth marketing. So this is a nice slide I got from my colleagues. So it's about all the madmen, all the creative persons, but at a certain moment, maths, data, they become very important. And that's why I'm here. And I would like to bring you a bit of math in this webinar. So just to put the expectations right. So the audience today is really marketeers today. So it's not for new hires to become a data scientist, because that's like a total other story. I'm not going to make things very complicated. So I'm going really to talk about what data science can do for companies where we work for and we work in. When we speak about data science, first we need to start with data. If there's no data, it's going to be really difficult. So just this is a kind of a warm-up where you have on one hand a lot of data coming from the business processes. And it's all about managing and optimizing all those processes. On the other hand, you have a lot of customer data, transactions, behavior, things we ask to our customers. And it's all about making those interactions with our customer more valuable. There's a lot of data as well as a product. Think about Google Maps, the weather data, where you have a lot of weather predictions. If we talk about data, we need to talk about big data too. So this is like one of the buzzwords we're hearing already a couple of years. But in fact, with a lot of companies going into digital, there's a lot of data being produced on the internet and on the mobile devices. So that's where the whole big data comes from. So it's first a lot more volume. You won't be able to put that in your Excel anymore. You need really tools to work on those data. It's as well, second thing, the variety of data. It's not only structured data, it's a lot of unstructured data. Think about language, and third thing, about velocity. all the data goes a lot fast. We want to interact in the moment. So today we talk about data science, but in fact data science is a broad concept. It has to do everything about extracting knowledge, insights from data. So one of the things is now, okay, what's the difference between data science and analytics? So most of you people work already with analytics. Think about Google Analytics. The key between the two is really, with analytics, we know what's the question and we know already the answer. We know how to get to the answer. About data science, it's like a step further. It's like a lot of questions we don't know yet. And it's all about insights. Let me give you an example. If you look, for instance, at Amazon, all those recommendations, how they do it, and most companies do it, it's not only the things we know. It's not customers who looked at one product, they looked at another product. There's a lot more things behind it. They look as well at you as a customer or your similar customers like you. So there's a lot of models that we cannot capture ourselves. And that's where we use data science for. A few buzzwords as well. When we speak about data science, you hear a lot of artificial intelligence. And that's something that's already been happening for many, many years, from the 50s, where we want computers to become smarter and to behave and mimic our human intelligence. One of the sub disciplines is machine learning. And those are all the algorithms we use today a lot. It's really to find the relationship between data. And one of the things which is like really popular for the moment is deep learning. A few algorithms as well. I'm not going to spend too much time on this one here. If you guys would be new data scientists, I would talk a lot more about it. But remember, one of the things is like unsupervised learning. It's like all the clustering where you have data and just put some algorithms in there and you're going to try to find segments so that let the data speak for itself. And then you got all the supervised learning where you know, where you have a kind of a target, where you want to learn towards something. And today I'm going to speak in the case about a kind of a classification. Point I want to bring here as well, data science is not bringing value only for the business. It's not only about optimizing conversions, sales, but in fact it brings as well value to the customer as well. It's like to be more relevant, more personalized, things like that. So it's good for both. So this was a bit the theory. I would like as well in this webinar explain a bit how it's done, okay, with a concrete example, show you the different steps how to get to an outcome. So one of the cases I want to bring here is in fact a fictive, not a real case. And the idea here is that for an online retailer, when you have like an e-commerce shop, you have as well transactions. And the idea here in the case is like, okay, what of value is there in the data? The idea about, okay, how are we going to get some value out of it? This is a bit structure your ideas, what to do. And on the first thing, what you need to think about, okay, what's the purpose? Like in this e-retailer, it's about our new customers, bigger carts, shopping carts, or make the customers come more often. Grade out the new customers, because new customers, you don't have already transactions for it. So I'm more focusing on existing customers. The next step is like, okay, with data, what kind of value can you get? And in fact, you can distinguish 4 kind of categories. So it's first insights. So data can bring you insights. It can go from a kind of a customer segmentation where you're going to start clustering your data and find segments. They're going to pop up and you're going to start profiling them. So you're going to get an idea of what kind of customers you have. It's about if you have feedbacks, customer comments, to start text mining them and to see with sentiment analysis to see, okay, what are they talking about? It's as well as revenue forecasting. On the other hand, you got targeting. That's more what kind of customers. So it's like thinking about What's the customer lifetime value? Okay, we have a customer today, but what would that customer become in 1 year, 2 years? We've got a lot of RFM models. It's like recency, frequency, monetary value. It's looking like customers who haven't been visiting the shop for a while. What can we do with them? Another problematic is cart abandonment. It's like a lot of visits, but not a lot of checkouts. So people put stuff in their cart, but they're not checking out. You can do as well optimum pricing, fraud detection. Another big thing is customer retention, making sure customers stay with us, so we don't always have to find new customers. We can keep them as well. A third pillar is personalization. It's making the whole experience for the customer a lot more personalized. You can do that with saying the first name to your customer when he logs in, but it can be as well with offers, recommendations very specific for that customer, which are more in line with their interests and needs. Fourth thing, but in here for the retailer, I didn't find any relevant ideas, is context. Is really looking at, okay, I have my behavior, what are the others doing? How can I compare my behavior, my things compared to the others? One of the things what I've done for this case is looking, okay, what are the data we have today? And I picked up for this today, the cart abandonment. One of the reasons I'm going to explain in the next slide is the data I have. And the next point is really looking, okay, what data do I have today? What data I don't have yet? Or what data I need to buy? It can happen very often that you have a splendid idea, but for the moment you're not capturing the data from your operational systems and you're not keeping that data. So one of the things might be here to say, okay, we're not capturing that today, let's put that up. And after a couple of months, we're going to have a new data source. And on the last thing, when, okay, put it into a plan, work out a technical solution, come up with the business processes, and always first do a proof of concept. See if there is something in your data or not. It's not a good idea to set up the whole infrastructure and at the end to see, okay, there's hardly anything in our data. It can happen as well. So, okay, a data scientist. So where does he come into play? So in the first, you start with all the data. So you got all the data in your operational systems. It's not a good idea to start querying or starting to manipulate your data in your operational systems. A data scientist can start querying and making big calculations. It's never a good idea to do that in your operational systems. Definitely not, because it can break up your operations. But that's where you have data engineers pulling the data out of your operational system into kind of data lakes. After that, that's where the data scientist comes into play. So the first thing he needs to come up with is a concept. Okay, what I'm going to do, what I'm going to model, what's my use case. In the next slide, I'm going to show an example of that, how we're tackling this here. Next thing, in his own environment, it's kind of a sandbox called in most companies. It's where the data scientist is going to prepare all its data. And that's where there is a lot of effort being put into it. It's cleaning the data, but making sure as well it's created that way that it can fit into the next step. And that's where the statistics come into play, the data modeling. The moment you have your model, then you have to go back to your operational systems. So it could be that it's insights, but other times it's really I'm applying that model to the business today. And one of the final things as well is data visualization. It's all about dashboards, things like that. So let me first explain a bit the data. So this is real data that's coming from, that's open source today. We found in Kaggle. So it's anonymous data. It's 1 month of transaction of an e-tailer. In fact, the data looks it's very structured data. It's really a user ID, a session, what the customer did, viewed, or put some products like products here, product ID into a cart or removed it from a cart. So it's like 1 month of transactional data. It's like something like 4 million records. It's not that much. That data is not ready yet. Let me first explain the idea. So the idea what we want to do here is cart abandonment. Okay. So one of the things we see in e-commerce is that a lot of customers, they visit your web shop, they put stuff in your cart and then go away. So it's like different from the brick and mortar shops where when you put stuff in your cart, it's really difficult to just leave your cart and go home. But in the digital world, nobody cares. And one of the things most e-tailers see is that they've got a lot of visits and in fact a lot less purchases. So a lot of customers, they just come and visit your shop. One of the problematics is cart abandonment. It's like, okay, they put stuff in the cart and then go away. One of the things we see is like between 60 to 80% they leave. So in the data, what we've seen is that only 19% of the customers, eventually within the month, they're going to finish the transaction. So we see that all customers in the first week, there are a lot of customers, they just abandon their cart. But eventually after 1 week or within the week or within 2-3 weeks, they come back and then they finish the transaction. Okay. So the idea here is to improve the abandonment rate. So there are like a few tactics what you can do. It's like optimizing the process or triggering afterwards emails. But one of the things we are considering here is to retarget our customers with an incentive. If we can determine customers who are likely to return, those ones we're going trying to facilitate the process. But customers who we think they might not return or very unlikely to return, we could give them an offer or an incentive like, okay, for you now, if you finish your transaction within the week, we give you a free shipping. Okay, so the idea here is to first do the data science on and determine the customers splitting up into likely to return and unlikely to return. And on the second step is then to look, okay, how are we going to tackle that? What are we going to do to come up with campaigns? So what I was explaining earlier on, so when we have the data about all the transaction, you cannot fit that into a kind of an algorithm. So a big chunk of work is done in a kind of an ETL tool, and here I'm using the Anatella from it's a Belgian software. And here, in fact, I'm working on a kind of a target, defining the target, and here I'm defining different kind of variables. So where you come up at a certain moment at user level, with at the end a target with 0 they didn't purchase and 1 they purchase. Okay, and then we created a few variables: how many products they put in the cart, how long they were at the session, how long did it take, if they came back or not. And the idea now is to find a kind of a relationship between what happened in the first week and if eventually they finished the transaction or not. So then the fun part comes, and it's where you create your model. It's really where you're going to apply your algorithms to it. You have several software who can do that. You can do that with coding, with Python or R, but you have as well commercial software. So in the case, I've been using Dummies to do this. And the idea is here that you have your data ready, and now a software is going to start releasing algorithms to it to find the relationships and to come up with a kind of a model. So the model here I created. So those are the variables I've put into play. And one of the outcome here is a lift curve. So when I told you there was 19% who eventually finished the transaction. So if you look at your 100% of your customers, if you would have known the future, you would have been able to rank all those customers and tell, okay, 19% of my customers, they're going to finish the transaction. If you don't know anything and you just do it randomly, if you target 20% of the customers, 20% of them going to finish their transaction. What's now the nice thing about a prediction model is that it can give a kind of a probability for everybody to finish its transaction. And if you at a certain moment you have your probabilities for all your customers, you can start ranking your customers from very likely, which is here, to very unlikely to be there. And what happens is that your model here, so the customers, the 20% most likely to finish the transaction, you're going to see that 40% eventually will finish their transaction. And that's where you can start thinking about marketing campaigns by saying, okay, I'm going to target my top 30% and I'm going to have 60%, 50 to 60% of my transaction finished. So I'm not going to tackle too much on those ones, but perhaps the customers who are very unlikely to finish their transaction, those ones I can do something with it. So the moment you created your predictive model in your sandbox, at a certain moment, you're going to apply that model and put it back in the production system. So that's where you can make predictions and start doing stuff with it. So this was the case about the retailer. Now I would like to continue a step further. So now we know with what kind of customers who are likely or unlikely to do something. But now the big question is like, okay, what are we going to do with it? And that's where I would like to merge the data science with growth marketing. So the idea here is in the beginning to come up with your data, to do your data analysis, to get your insights, your segments. And then the next steps is to come up with, define your experiments. Okay, what are we going to do now with those customers who we know they're unlikely to finish their shopping transaction? And then you have like a whole procedure, which is like similar in the whole growth marketing, where you're going to think what are the things what we could test, and then to run your experiments and to see, okay, if we're going to give this, it works, that we're going to give that, it doesn't work. And the idea is as well, after your experiments, because with your experiments, you're going to manipulate a bit the customer behavior. And at a certain moment, you're going to need to return and redo your model as well. And on the sixth point here, that's really a step higher. It's like when you're doing a lot of experiments, at a certain moment, you can start applying your data science to your experiments itself to say, okay, what kind of experiments you need to do or you not need to do. Just want to give a few key messages. One of the things that's really important for you guys, tag and label everything always. So make sure you create data. For all the ones, all our growth hackers, start building a repository. Keep track of all your experiments as well. Never get emotional. Only look at the numbers. Look at your experiments. Look at your models. And that's one of the things we strongly believe is like the whole growth. We can predict stuff. It's maths. Time for some questions and answers. Full power to the data teams and marketeer is following. Our marketeer still leads. I think there's always should be a kind of a mixture between the two. So the marketeer needs to come up with ideas. That's one thing. And then you got the data parts to confirm it. And as well to come up to find ideas in the data as well. But never, don't solely put your trust in a data only, you need as well creativity. It's the mixture between those two who's gonna create some added value. Another question, do we need to invest in data scientists? As a company, first starts with data analysts, make sure your analytics are right. And then the next step is to come up with data science for the next phase of analytics. So the software I used was called Timmy, and the TL I used was Anatella. I'm going to share afterwards where you can find it, but if you do just to timmy.eu, you're going to find it. Okay, I think I got everything. Thanks everybody, and stay safe. Bye.